Hello, class. Our opener brings us back to the time we would write expressions from words in a problem. So write an equation that represents each phrase, and really just say expression. So the quotient of 6 and a number x is 14. Oh, I guess, sorry, it is equation. So the quotient of 6 and a number. So quotient indicates division. So we'll divide by x, and is meaning equal to 14. But that's all we're going to do. That's all we're being asked to do. 7 less than a number x is 13. So remember, this is the one where 7 less than implies we're subtracting 7 from x. So we're actually going to say x minus 7 is being equal to 13. Okay. So now let's do the same with inequalities. And that's what our new unit's on, is inequalities. So we have all numbers x less than or equal to 7. So let's set up our kind of chart here. When the arrow kind of is pointed to the left, that is our less than. The line underneath means equal to, less than, or equal to. Okay. And then this is just less than. And then when it's pointed to the right, it's greater than. So the first one would obviously be greater than or equal to. And then the last one is just greater than. And then I'll throw in one more for free. I honestly can't remember how often we deal with this in this unit, but it is not equal to. Okay. All numbers x less than or equal to, so that'd be this first one up here, negative 7. 6 less than a number k is greater than 13. So here we've got that similar structure that we had in the first problem. 6 less than implies it's k minus 6 and is greater than, so that would be my inequality symbol, 13. Go ahead and give the you-do a try. So we got all real numbers p greater than or equal to 1.5. So p greater than or equal to 1.5. And then we have the sum of t and 7. So sum means plus. So t plus 7 is less than negative 3. Okay, so let's go ahead and work through if these numbers, negative 3 and negative 1, are a solution to this inequality. So I'm going to do that by substitution. I'm going to get 2 times my negative 3 plus 1. Is that greater than negative 3? Okay. So we got 2 times negative 3 is negative 6 plus 1. And it looks like an answer is jumping off the page at us. We have negative 5 is not greater than negative 3. So negative 3 is not a solution. And then we do the negative 1. 2 times negative 1 plus 1 is that greater than negative 3. So we get negative 2 plus 1. Is that greater than negative 3? We get negative 1 is indeed greater than negative 3, so this is good. This was no good, and this was good. All right, go ahead and take a second. Consider negative 1, 0, 1, and 3. Are they the solutions to this inequality here? Okay, so I went ahead and wrote down some of the work ahead in advance. And we can see that negative 1 and 0 were not solutions. They didn't end up working out. Remember that negative 7 times negative 1 gives us a plus 7. That gives us 20. less than or equal to 6, but that, of course, isn't true. The 7 times 0 cancel. We had 13 less than or equal to 6. Also not true. And then we get 13 minus 7 on the third one, which gives us 6 less than or equal to 6. That is true because those are equal. We only need one of the two. It either needs to be less than or it needs to be equal to, which is why the last one is also true. We got negative 8 less than or equal to 6. Negative 8 is less than 6, so we're good there. All right, so let's talk about graphing inequalities. What is the graph of 2 is greater than or equal to A? I'm actually going to reverse this. I'm going to say, so 2 greater than or equal to A. I'm going to flip that around, but that turns into A is less than or equal to 2. Okay, now I forgot to put my equal to sign. Let me put that in there. Okay. But this is the better way of graphing it, because when I draw my number line, and you'll find I'm not picky with the way you graph your inequalities. Go ahead, draw a number line, place your own value in the center. I trust you guys to know that lesser values are to the left, greater values are to the right. So you don't feel the need to plot any more points than that. We have to remember that when we have the equal to, we're putting a solid point down. And then it's less than, all less than values are to the left. So I'm going to shade to the left. Now, if we had gone based off of the original inequality, 2 is greater than or equal to A, I would still graph 2 solid point, but I'd have to think 2 is the greatest value that it can be, so I would have to flip my logic around. It's easier, in my opinion, to flip the inequality around than it is to flip the logic around, so keep that in mind. And go ahead and give the graphs of these three inequalities. So the graph of x is greater than or equal to negative 4. Since it's greater than and not greater than or equal to, we'll put the open circle and it's greater than, so we shade to the right. Similar idea with c is less than 0. Open circle because we're not equal to, but we shade to the left because it's less than. And then finally, for the last one, I did reverse my order. N is greater than or equal to 3. So solid point, shade to the right. All right, let's go ahead and write inequalities given the graph that we have for each. So I've got 5 here. Now I'm going to just use the generic variable x, and we're to the left. That would be a less than, and then I see a solid point, so that would be equal to 5. And we're done. The next one, we have x, we're to the right, so greater than. We're an open circle this time, so no equal sign, and we're greater than 2. For the next one, x is less than, because we're shading to the left, no equal sign, negative 2. And then finally, x is greater than, and for the solid point, equal to negative 5. All right, go ahead and give these a try. Okay, so we've got, remember, anytime we're writing these equations, we've got solid points give us the equal signs, like the first and the fourth. Open circles give us no equal sign, like the second and the third. And then shading, the left, these two to the left, are shaded to the left, so that means those are less thans. And these two on the right are to the right, so those are greater than. All right, final problem, kind of thinking about inequalities in the real world. We have Netflix starting at $6.99 per month. If you don't have Netflix, they will start their pricing at $6.99, and then the more screens you have available to your account, they will charge you more. Generally with, I can't remember if Netflix is an ad or no ad service. They might charge you more if you're going no ads. So starting at means we can go $6.99 or more. So we'll say X is greater than or equal to $6.99. And then the speed limit sign Let me get a new color. Speed limit, for those freshmen starting driving out, that is x is less than or equal to the number that is on the sign. You can go less than legally, you can go equal to legally, but legally you cannot go greater than. Go ahead and complete the exit ticket. Thanks for watching.